Professor Bumbleweed here. Space travel looks shiny, but it runs on fuel, math, and ignoring gravity's rude opinions. This quick explainer shows how rockets evolved from early experiments to satellites, humans in orbit, moon missions, space stations, and today's reusable boosters that land like they own the place. Space travel contains two ingredients: serious engineering and humans acting shocked that physics stays consistent. This short explainer keeps it entertaining and genuinely informative, walking through rockets, orbit, moon missions, space stations, and modern reuse. Time to get closer and actually see what is happening. Space travel starts with a giant compromise. Carry your own oxygen, burn it, and throw the hot gas out the back. That is why a rocket works in vacuum. The gimbal motion shows steering. The nozzle tilts, so the thrust vector tilts, so the whole stack turns. Once a rocket reaches orbit, it is not up there. It is falling around Earth fast enough to keep missing. Early satellites prove orbit works. Early crewed capsules prove humans survive launch, weightlessness, and reentry. Not comfortable, not glamorous, but alive, which counts as success. Moon missions require more than a big rocket. They require a plan that survives reality. The Saturn V class stack carries multiple stages, and the spacecraft itself splits into pieces with different jobs. That exploded view shows why. One part travels, one part lands, one part brings everyone home. The moon landing is controlled falling with a throttle. Dust does not swirl like smoke because there is no air. It sprays outward in sharp arcs. Coming home matters just as much. The heat shield survives re-entry, parachutes slow the capsule, and the ocean turns a spacecraft into a bobbing bathtub toy. Reusable spaceflight sounds easy until you try reusing a vehicle that returns through a plasma furnace. The space shuttle flies like a rocket on ascent and like a glider on landing. Those tiles and leading edges handle brutal heating and small damage matters because physics stays extremely petty. Staying in space is logistics disguised as science. Vehicles dock slowly because crashing into a station is unpopular. Inside, maintenance never ends. Filters, fans, and careful tool control, since floating debris becomes a tiny orbital menace. Even water behaves differently, clumping into blobs because surface tension wins in microgravity. The booster landing sequence is a full-on ballet, just with more fire. After separation, the stage uses grid fins to steer through thick air, then fires engines to cancel speed. The landing legs act like shock absorbers because arriving at 0 meters per second is preferred over arriving as spare parts. In space, small forces matter because nothing rubs against the air. Tiny thrusters rotate a spacecraft for pointing and docking. Burns at the right point of an orbit change the orbit shape efficiently instead of wasting fuel. Electric propulsion pushes gently for months, which is boring to watch and amazing for navigation. Going farther means treating space travel like infrastructure, not a one-off stunt. Vehicles dock, transfer propellant, and reuse hardware where possible. Cryogenic fluids slosh and boil, so tanks need baffles, insulation, and careful operations. Habitat testing on Earth looks plain, but it reveals the boring failures before they become dramatic failures. Space travel does not magically get easier, it gets smarter. Low-thrust engines push gently for a long time. Gravity assists bend trajectories by borrowing momentum from a moving planet, which feels like cheating but counts as physics. Long trips also demand shielding, redundancy, and emergency procedures because space does not offer refunds. Quick summary, using that frozen image on the television as the map. Rockets beat gravity by throwing mass backward. Orbit means falling around Earth. The moon missions prove navigation, landing, and safe return. The International Space Station proves long stays. Reusable boosters prove launches can stop being single-use fireworks. Thanks for sticking with the silent chaos of space travel engineering. If the visuals click, hit like so it is obvious which topics land and which ones crater. Then write topic ideas in the comments, because my sarcasm needs new material and the animators need something to animate. See you soon!